Welcome back to Spark Rise, everybody. Today we're going to be diving into CPU performance and embedded systems, which are two fundamental topics in computer science that affect how our devices operate. Before we get into the video, can I just ask you to drop a like and subscribe and a comment if you've got any questions or queries, and it really helps go the difference. We've got loads of other videos like this covering content on our channel for maths, computer science and STEM subjects, and we've also got loads of past paper revision videos on there too, so go over, have a look, and hopefully we can help boost your grades. So, what affects the performance of CPU? So obviously today's processors are so incredibly fast, but there are still three main features that affect the performance of CPU. These are clock speed, cache size, and number of cores. And we touched on cache size and clock in previous videos about the CPU and the von Neumann architecture. Let's break these down. Clock speed. So every CPU has an internal clock which synchronizes the computer's components. The clock sends out these regular pulse signals to make sure everything stays in sync. It's measured in hertz, which is the number of fetch decode execute cycles per second. The higher the clock speed, the more instructions processed, so the faster computer and the better performance. So higher clock speed, better performance, because you're processing more instructions per second. That is it. It's nice and simple. Cache. Cache is a small high-speed memory located inside of the CPU. It stores frequently used data and instructions, so the processor doesn't have to repeatedly fetch them from a main RAM. A larger cache means the CPU spends less time waiting for data, therefore improving performance. Very simple. Cache speeds up processes. You've got your frequently used data and instructions. They're faster to access. The bigger the cache, the more that can be accessed. And we just got to remember that cache is really expensive and really small. So we can't have infinite cache. Number of cores. So a core is an independent processing unit within the CPU. Each core can handle its own fetch decode execute cycle, meaning multiple cores can work together on different tasks at the same time. Single core processors process instructions one at a time. Multi-core processors process multiple instructions at once, which gives a performance boost. All our modern day computers are multi-core. You hear about it, it's a quad core or it's a dual core. That's what we're talking about. We're talking about individual processing units, each one of which can carry out its own fetch decode execute cycle simultaneously. So therefore, the more cores, the more instructions are being executed per second, so the better performance. Many modern computers now have 8 or more cores, which is particularly useful for gaming, video editing, and multitasking. And I know my laptop has, I think, 8 cores. Not to be confused with GPU cores, which is a topic for a different video. So, in summary, a higher clock speed, larger cache, and more cores generally lead to a faster and more efficient CPU. Well, next we're going to look at embedded systems. These are the hidden computers in everyday devices. Not all computers are designed for general use. Some are built for specific tasks. Think about things like your dishwasher, your fridge, your digital watch. They're not like general purpose computers because they're designed to do one specific thing. Your fridge keeps things cold and maintains certain temperature parameters. Your watch tells you the time, and your dishwasher follows a set washing cycle. And what actually is an embedded system? Well, it's a small computer within a larger machine or device. So we've got a washing machine. It's a tiny little computer that carries out a very specific process. So instead of being a general purpose computer, it's programmed to perform one specific function. Examples of embedded systems, as we talked about: dishwashers, washing machines, digital watches, GPS systems, and refrigerators. And we've got some lovely pictures of them there. So basically, all you need to know for your GCSE exam is an embedded system is a really small computer built in within a larger machine or device. It's part of a larger process in general, and it carries out one specific function. And you almost guarantee you'll get asked the question to identify some examples of embedded systems. So these are always some good ones to go off. When you start going to cars or to slight phones, it can get a bit touch and go because actually a lot of cars now do have an actual CPU in them and a full processing system. So you're best to stick to what we call dumb devices, so your dishwasher, washing machine, tumble dryer even, things like that. So let's look at some advantages of embedded systems. Well, they're optimized for efficiency and cost effectiveness. There's fewer features, they're cheaper design and manufacturing, so a lower cost overall. They're also extremely energy efficient. These are very, very simple machines. They don't need lots of power to run like a modern day CPU would because they're just not doing as much. So they can run on really low power and even batteries in the case of a digital watch. There's less processing power needed because they don't require high performance CPUs. It just makes them more affordable in general. So our main advantages are low cost and energy efficient. To talk about, and then we can also talk about they're just in general is a lower processing power. They're easier to make, they're easier to implement. That is our advantages. So to sum up, CPU performance depends on clock speed, cache size, and the number of cores. Embedded systems are specialized computers found in everyday devices, which are designed for specific tasks. Both of these concepts play a massive role in the technology we use every single day, if it's from our powerful gaming PCs or to simple household appliances. Well, that's all for today. So if you found the video helpful, please drop a like, comment, and subscribe. Hit the notification bell, and you won't miss out on any new video releases. Yeah, thank you so much for supporting the channel, and have a good day.